Good morning, everyone. Welcome to the EasyPower Thursday webinar series. My name is Jim Chastain. I'm your host for today's session. My apologies for the changes in the presenter and the topic. They were due to circumstances beyond our control, so I do appreciate your patience. And this is the last webinar for the year. And so we do very much appreciate your attending today. And as we are in the habit of doing, before we present the material, we'd like to conduct a couple poll questions and get some feedback. No obligation or liability. It's strictly just getting some feel for the pulse of the audience. So the first question is, do you or any of your clients require work on equipment rated at greater than 40 calories per square centimeter? And if you would please indicate your selection or your opinion. This is a topic of active discussion around the industry, and I, for one, am curious to see how, at least in our audience, the opinions range. So it looks like we're close to a quorum. Let's give this another 5 seconds. I'll share the results. Again, we appreciate your attendance and your participation. So here's how folks have weighed in on this. And it looks like there's a majority in the negative, but some that do have to take this into account. Excellent. And then the second question is, what is the minimum daily rating for daily wear clothing that you or your clients require for your qualified workers? And again, this is another topic that comes up frequently when people are trying to decide what to do about labeling or the minimum thresholds that you can allow or permit people to work on during typical maintenance. So expect a little wider variety or variation on the theme as far as people's opinions. We have pre-recorded the presentation today, and due to the time zone restrictions, Mr. Pollard will not be able to join us online, but if you would please record your questions using the questionnaire in the control box, we'll be able to respond to those sometime via email at a later time. So it looks like we have a quorum here. Here's how people have weighed in on this. Not surprising, but it's a good variety of opinions. Excellent. Thank you for participating. Jim Pollard is a ongoing contributor to the EasyPower webinar series. And if you give me just a second, I'll queue up the video and say welcome to Mr. Pollard.
Hi, my name is Jim Pollard. I'm the guest speaker for the EasyPower webinar this week. My presentation is Arc Flash PPE, impacts on both human performance and human error. The presentation I prepared for this week's webinar is a quick introduction, an Arc Flash overview, anatomy of Arc Flash PPE, how it's used as a risk control, the reduction of human error, and a quick FAQ. Disclaimer, this session is not a qualification training for electrical workers. You are cautioned to consult the applicable standard, be it CSA Z462 or NFPA 70E, prior to making any changes in safe work practices. And the opinions expressed by myself are my personal technical opinion. As the webinar presenter, I'm a voting member on various different applicable standards, including the CSA Z462, ULC S801, very much involved in social media, so please find me on LinkedIn. and I've authored several different trade magazine articles. My company in Canada is Unlimited PPE. We represent the Oberon Company, ESPS, Electrical Safety Program Solutions Inc., which is a division of Danatech Educational Services, and Proxy Corporation. So the Oberon Company is specific to Arc Flash PPE. They are the pioneer in the industry, having over 30 years experience in manufacturing Arc Flash PPE. Their website is arcflash.com, and they manufacture products such as Arc Flash suits, arc-rated face shields, and much, much more. They are located in New Bedford, Massachusetts. All their products are manufactured in the United States. The Arc Flash overview. So what is an Arc Flash? Most of us on this call would understand what an arc flash is, but just a quick overview. An electric arc is the passage of substantial electrical current through ionized gases. An arc flash hazard is a dangerous condition associated with the possible release of energy caused by an electric arc. Typically lasts less than 1 second. We're talking about extremely high thermal energy, and it's explosive in nature. It can cause a pressure wave from expanding metallic material into vapor. When can it happen? So workers perform tasks that put them at risk, including voltage testing, removing bolted on panel covers, inserting, removing circuit breakers, just as a few examples. How can it happen is a conductive object gets too close to an energized conductor or circuit part and ground. An electric arc superheats and ionizes the air, allowing for a path for the electrical current to flow. And it does require sufficient voltage. The electrical current can sustain itself and then transform into an arc flash. What is the cause? This is where we're spending more time and effort in our industry on human error. And so essentially the most common cause for an arc flash is human error in performance. When do you need protection? The human threshold for a second-degree skin burn injury is approximately 1.2 calories based on the Stoll curve. So if you take a cigarette lighter using the image on the screen here, it's about 1 calorie if you hold that about 1 inch away from your fingertip for 1 second. The applicable standards in the industry that apply to Arc Flash PPE, I'm located in Canada, so I put CSA Z462, and there's also the NFPA 70E, which is the global SEED document or SEED standard for any workplace electrical safety. Other standards include NEC, ULC, IEC, and many more. We have a revision cycle here in North America for the NFPA 70E and CSA Z462. At the time of this presentation, the most current edition or publication is 2015. We are about to introduce and publish the 2018 edition. And as part of the technical committee, we are working on 2021 and future additions to the standard. Applicable PPE standards, there's a variety. I mean, it includes ASTM standards, CSA standards, ANSI standards in the United States. You can look at almost every single individual component that a worker wears for protection from the electric arc as an arc flash, and there's an associated standard with each one of them. In my presentations, I often get the eyes glazed over effect within the audience when I review all these different standards. It just sounds like a bowl of alphabet soup. Just to keep it real focused here on the presentation, we're going to talk more about the anatomy of Arc Flash PPE, how we're using it as a risk control, and then more of the leading edge type information and subject matter, which is how do we reduce human error. By reducing human error, we can certainly reduce the likelihood of an arc flash occurring. So in terms of the anatomy of Arc Flash PPE, it's personal protective equipment consisting of specially designed and appropriately tested products suitable for use by workers that need protection from the thermal effects of an arc flash hazard. Specially designed, appropriately tested, and suitable for use are the 3 key points. In terms of how it works, so Arc Flash PPE prevents the burns. So we have the initial stage of an arc flash event being the radiation wave. We have a pressure wave that follows, and often we have debris that is being shot at ballistic velocities at the worker, such as copper particles. The thermal energy equals the incident energy, that is the calculations, and the partners here at EasyPower do a great job in terms of helping you do those calculations to determine what PPE is needed. So identifying the severity as part of the risk assessment, Arc Flash PPE is designed to protect against the thermal effects of an arc flash. I have a few different items here listed, such as the arc plasma temperature, the surface of the sun. So the core of the arc flash or the arc plasma is approximately 4 times the temperature of the surface of the sun. We have identified clothing ignition, burning clothing, second-degree skin burns. Again, that's about 1.2 calories. The clothing ignition causes fatalities. That's the #1 leading cause. Arc flashes rarely cause fatalities unless the worker's clothing ignites. And it's important to note that only natural fiber clothing can be worn under Arc Flash PPE. The reason for this is that it won't melt or drip. Natural fiber clothing will certainly burn, but the melting and dripping is where we increase the depth of injury in terms of the burns, and it increases the severity, so the injury caused to the worker. In review, Arc Flash PPE, we have 3 different points. So again, specially designed, appropriately tested, and suitable for use. Those are the 3 key points you want to consider when you're reviewing Arc Flash PPE. The testing that we run in terms of certification and the creation, so the R&D behind Arc Flash PPE, it's based on exposed skin. So industry basis point for a second-degree skin burn, again, is 1.2 calories. I mentioned previously how the depth of injury is the actual degree of the burn. We have 1st degree all the way through to 4th degree burns. A second-degree skin burn is recoverable. We can actually rub some cream on there. There's treatments that we can use, but a 3rd degree is not. So we want to avoid that 3rd degree skin burn injury at all costs possible. What is an arc rating? So there's 2 different types of arc ratings that are defined by the ASTM F1959 standard. We have the ATPV, or arc thermal performance value, which is the incident energy level at which there's a 50% probability of sufficient heat transfer to cause the onset of a second-degree skin burn injury. And then we have a break open threshold, or EasyPower, where at which point the incident energy level is 50% probability of the formation of holes or tears in the layer closest to the skin. We test the products at a high current testing laboratory. So for example, with the Oberon Company, I was at Kinetrix Laboratory last week. We were running some testing on some Arc Flash chute hoods. The test setup that I have on the screen currently, this slide shows the F1959 test setup, which will test panels of fabrics in order to determine the arc rating. The ATPV test report, which is hopefully the result of your day at the testing laboratory. And it's essentially, we're going to determine the 50% probability of that second-degree skin burn injury. And when you look at these test reports, you can actually see the probability of a burn from 5% up to 90%. However, it's the 50% probability point that's going to be labeled on the garment itself or on the product. Following a test, we look at the fabric, we evaluate it for break open. This helps us determine whether we're going to rate the fabric as an ATPV or an EasyPower. The Faceshield and hood testing, it is a different setup. So it's the ASTM F2178 test setup. Again, the same high current test laboratory. The screenshot that I have up on the webinar currently shows on the left-hand side the test before it's conducted, and on the right-hand side is after the arc flash chute hoods have been exposed to an arc flash. Testing for Faceshields and hoods is similar. However, the advantage of testing with 2178 is that we're actually testing actual products, which is fantastic for the workers to know how the product that they're going to wear and use for protection to reduce the injury based on the severity and how that's going to perform. Indifferent to a fabric test where the fabrics are tested, the arc ratings are determined, yet we don't fully understand how the manufacturer may cut and sew the material and create the finished product that you're going to wear for protection. So I mentioned about last week with Oberon at the test laboratory. I just put a couple pictures here in the presentations. We have Jack Hirschman, the founder and CEO at Oberon. We've lined up all the hoods. There's 20 test specimens there on that desk. And then on the right-hand side, you can see what we've done with those test specimens in testing. So over 20 samples were used to determine the arc rating. And then the labeled arc rating is the lower of either the hood, which is a combination of the front, meaning the face shield and the fabric, in the design of the arc flash chute hood or the fabric itself. So in the case of Oberon hoods, just for example, the front of the hood with that clear gray lens provides a significant more protection compared to the fabric itself. So we rate the hoods as the fabric rating, and that's because if the worker is facing away from the arc flash, the weakest point of the hood would be the fabric itself. How to identify arc flash PPE? So this screenshot shows us the label from a typical garment or arc flash chute hood. The ASTM F1506 standard is the performance standard that the manufacturers must follow. It provides guidance and instruction on how to label a garment. So I've identified those different points here. It's important to note the arc rating itself, the applicable standards that it's in compliance with, the care instructions, so cleaning, and there's even an identification code tracking system. In Oberon's case, we use a barcode and individual serial number. So each and every garment or product that's manufactured is assigned an individual number, which is great for myself as the Oberon rep in Canada. If I'm visiting with an end user and they have a very old product, I can actually send that serial number back to the Oberon factory, and they could tell me exactly what day, what year it was manufactured. So great due diligence for the end users, for the customers that wear the products. The laboratory evaluation, we're looking at the performance. So testing is completed to measure the performance of the product. ASTM standards are used to certify that product. What we also conduct at the laboratory would be scouting or some type of evaluation. So material response evaluation, we're looking for break open, melting, dripping, deformation, after flame time, shrinkage, ignition. Those are just some of the examples of what else we do at the laboratory as part of the R&D that we invest in manufacturing the products. Arc Flash PPE never expires. The typical Arc Flash PPE can last 5 to 10 years, often longer. So properly care for and maintain your Arc Flash PPE. Pre-use inspections are required by the applicable standards. Repair and replace as necessary. What I do in my day-to-day activities is typically working with end users. For example, this week I'll be with an end user and auditing their actual products that they have all throughout their plant facility. I encourage everybody to do the same thing, at least on an annual basis. You know, you pull all the product out of the lockers, you have a look at its condition, you repair it if possible, or replace it if necessary. If your PPE has been exposed to an arc flash, it should never be reused again. Arc flash PPE is not perfect, so some situations could result with a worker being injured even while wearing their protection. The CSA Z462 standard recognizes that beyond the thermal effects of an arc flash hazard, other injuries can occur. Arc flash PPE does work, and potential burn injuries would be reduced and be survivable. Just important to note that there are elements to an arc flash that are unpredictable. So it's important that you wear your PPE, but it's not rock solid. You're not wearing a cinder brick wall for protection from the arc flash. When arc flash PPE fails, examples would be poor design, for specifically the interface, the non-FR components that could be used in the manufacturing process by some manufacturers out there that don't understand the ASTM F1506 standard and how to use that standard in manufacturing products. Workers' body parts could be closer to the source. So your head, your arms, etc. We actually consider your arms and hands to be expendable because we're doing the calculations, or EasyPower would do the calculations based on the distance from the arcing source to your chest and your face. However, we often work with our hands and arms extended towards the arc, and as you get closer to the arc flash, the incident energy would be exponentially higher. You know, distance is your friend. If you get farther away, it's the inverse square relationship, so the incident energy drops as you get farther away from the source of the arc flash. If the arc is moving, it can decrease the distance. The arc could be closer to the worker, and you're going to see some localized spots where we're going to have more heat than others. And equipment configuration, meaning convective versus radiant exposure. This image here from the test laboratory just shows an Oberon coat and bib overall. Again, that arc is rather unpredictable. So the arc does track, it does move. We show that image where I'm circling that one spot where we had focus energy from the movement of the arc. Thankfully, the design of the arc flash suit often is a bib overall with a coat, and then you have your suit hood. So there is sufficient overlap. So the corresponding area behind that darkened spot on the coat, on the bib overalls, doesn't show much damage. Therefore, the worker would not have seen enough heat. We shouldn't have had any injury whatsoever. The rules of thumb when you're using arc flash PPE is that it only works when you wear it. It's kind of obvious, but it's needed to be said. Never wear clothing that contains materials that melt, such as your underlayers or garment design. A question I had just recently from one of my customers was, what about your outerwear? You know, we're moving into the winter months, and questions come up about winter jackets. Well, if I have on my proper arc-rated PPE, such as my coveralls, balaclava, arc-rated face shield, and hard hat, and we need to layer up for some warmth, what type of a jacket should we be wearing? Well, the standards such as the NFPA 70E and CSA Z462 identify the outerwear, so a jacket or a parka, it also must be arc-rated. We don't want to be wearing just a regular jacket over top of our arc-rated clothing ensemble. All electrical specific PPE requires a pre-use inspection. You always need to wash your arc flash PPE separately from other garments, and always follow the manufacturer's guidelines for care, use, and maintenance. In Canada, I've developed different user guides for my customers to help them with the training. It's incumbent on the employer that when you provide PPE to the worker, that you actually provide them with training or instruction on care and use. So often the customers that buy arc flash PPE, they're not subject matter experts and they need assistance from the manufacturer. So those resources are available for you if you're interested. Common industry gaps that we see out in the market is a gap would be to evaluate arc flash PPE through learning about applicable standards. I mentioned all those different standards previously. It is a lot like alphabet soup, so it's difficult, and hence it is an industry gap. We often see that employers aren't thinking through how workers use their PPE. They're not preparing for an arc flash accident, such as the rescue, first responders, providing adequate arc flash PPE care and use training to the workers, not having an electrical safety program, and not reviewing existing arc flash and shock PPE to identify what needs to be repaired, reconditioned, or replaced as necessary. So those are common gaps that we should be addressing. Beware of PPE pitfalls. So a long coat suit design is often a pitfall in industry. If a worker were to squat, just like my image on the screen here with a worker with their knee on the floor, you can actually see the blue part of their coveralls, and that is a gap. So if a worker were involved in an arc flash, they could sustain some rather significant burn injuries in that exposed area. This type of a system is rather difficult for a worker to use because they have to keep their knees together when they squat. So we want to use, in my opinion anyways, we want to have a bib overall or a pant with the coat and have sufficient overlap. So we have lots of protection for the worker in the event of arc flash exposure. Beware of myths versus realities. This is still common in our industry that we feel there's a limit or a cap at 40 calories. You know, safe PPE does exist above 40 calories. Just on this last week, I was testing at Kinetrix with Oberon, and we were exposing products up to 117 calories without getting any burns. That was a 100 cal suit hood that we were testing. We couldn't actually get any burns. We were testing as high as we could. In the past, Oberon has certified a 140 calorie ballistic arc flash suit. So safe PPE does exist above 40 calories. It's not a limit. And really the arc flash, the incident energy does not directly correlate with the blast. So I could spend a whole webinar topic on just this alone, but it's important to note that blast pressure is not related to the incident energy. So moving on in the presentation, arc flash PPE is used as a risk control. And essentially before work is started, the applicable standard requires a risk assessment procedures completed, and that breaks down into hazard identification. So examples be shock, arc flash, and blast. Assess the risks, and then implement the risk controls using a hierarchy of controls. Now that hierarchy of controls would have Arc Flash PPE as the last line of defense. It's, however, the most readily available and commonly used control to mitigate the risk. Risk is a combination of severity and likelihood as defined by NFPA and CSA standards. So we look at the severity as being the potential arc flash or thermal energy measured as incident energy. And then the likelihood is where we rely on your safety related work practices, your safety management system. So an electrical safety program helps in terms of identifying the likelihood of an arc flash occurring. For example, your program, if it were following, say, ANSI, so some type of an occupational health and safety management system standard and its framework, would would have hazard identification, training, roles, responsibilities, your risk assessment procedures such as forms, workflow process, the standards. You see there's one arrow pointing towards the program, and that would be your NFPA 70E or CSA standard that's being used as information. So more or less a toolbox that would be used in order to build up your program, and then your program defines everything that surrounds it, including your electrical specific PPE tools and equipment, or Arc Flash PPE for this presentation's purpose. Who needs arc rated PPE? Well, we have electrical workers in the industry, and we have non-electrical workers. And non-electrical workers are not permitted to be performing energized electrical work. Therefore, they do not need any arc rated PPE. Electrical workers would if they're doing the typical work tasks that are considered energized work tasks, such as testing and troubleshooting. When is arc rated PPE not required? So it's not likely to occur when we have electrical equipment in a normal operating condition. And that's referring to the doors being closed, covers are on, there's no exposed components. The equipment is in a normal operating condition. So there's elements to what is a normal operating condition defined by the standard. And in a normal operating condition, we don't anticipate an arc flash because the likelihood of occurrence is so low that we don't require a worker to wear arc flash PPE. The arc flash PPE is designed to reduce risk. It actually reduces the severity of the bodily harm. So the injury to the worker is reduced by using arc flash PPE. And again, risk is a combination of likelihood of occurrence and the severity of injury or harm from a hazard. The severity, so the PPE then protects from the bodily injury. We reduce the severity by lowering the risk, so appropriately rated and suitable for use arc-rated PPE reduces the severity to a recoverable second-degree skin burn injury. And here I'm referencing again that ATPV, or the arc rating that we measure and determine based on the high current laboratory and the testing that we've done. The innovation in arc flash PPE goes towards reducing the likelihood. So new innovations in arc flash PPE reduces human error by improving human performance. A real simple example of this is that LED lamp on the upper crown of a face shield that I'm showing on this slide. If we could add more light to the work task, we improve human performance. The majority of all arc flash incidents are caused by human error. So by improving human performance, we lower the likelihood of workers making mistakes, and mistakes cause arc flashes. So the innovations in arc flash PPE, actually the PPE themselves, the PPE itself, it reduces the severity, and the leading edge technologies in arc flash PPE reduces the likelihood. So reducing human error lowers the risk. Improvements in arc flash PPE design and arc rated material technology minimize mistakes. Examples of this would be ultra lightweight fabrics, clear face shield and lens technology, comfort and productivity features. These are elements that are really important to a worker when they're using arc flash PPE. Arc flash PPE, for the most part, when it comes to electrical workers, it's seen as a barrier to doing your work. If a worker had the choice between wearing PPE or not, they're going to take the not option. It's always easier to not have any type of a layer between you and your work, but we know it's a necessity in order to reduce the injury in the event of an incident. So when you have to wear PPE, it's important that it is something that's not going to diminish your production. It's not going to affect your ability to perform that work task. And how to select arc flash PPE? Appropriate arc flash PPE is selected based on the potential thermal incident energy exposure as determined by an employer's arc flash risk assessment. So we look at two different methods. So incident energy analysis method, where we look to EasyPower for performing the engineering calculations. Alternatively, we could use the arc flash PPE category method. And selecting your PPE, make sure that the arc rating, so the performance, what we expect from the product itself is equal to or greater than the arc flash hazard. And then selection examples, we have here an example between a face shield or a suit hood. An arc rated hood shall be used when the estimated incident energy exposure is greater than 12 calories. And now reducing human error through the innovation in the arc flash PPE. So evolution of PPE design through our evaluation, our assessment of incidents within industry, that's what we've used to help learn from our mistakes. And what I mean by that is, here's one example from Canada, from Saskatchewan actually. So this happened in March 2015. This worker was racking in a circuit breaker. In this work task, they removed their gloves to operate a flashlight. And what occurred, Murphy's Law has it, if you take off part of your PPE, you're going to be involved in an arc flash. And in this situation, the arcing fault resulted in an arc flash measured at 140 calories. This worker had on a 70-calorie arc flash suit, which gave them protection for their face, their head, their body. However, the exposed hands received significant second and third degree skin burns. So the worker had commented on the image on the far left of the hood, saying, "This is the hood that saved my face and possibly my life." And I just put a few different images that this worker provided to me, documenting day 1, day 2, day 5, and day 10 of the process with the skin burn injuries on their hands. We do not ever want to take off part of our PPE. An example would be if we need work task lighting, that we make sure that our PPE provides that lighting. Workers need to see their work, and most times workers are just trying to make do with their current PPE. So effective work task lighting, here's just a snapshot example where you could add an LED light to an arc-rated arc flash face shield upper crown. If you're in the mining industry, you're familiar with this, where you have those lamps attached to your hard hat. Those lamps could be moved forward using a miner's lamp adapter to the upper crown of a face shield to provide light. And then specifically regarding face shields and the lens technologies for arc flash PPE, there are now gray face shields in the market. So compared to green, they are safer. And what I mean by safer is they allow workers to see their work clearly. They allow for 100% color acuity. So your colors are 100% accurate versus being altered or even shaded out based on the yellow or green lenses. When workers see their work task clearly, they make less mistakes. They lower the probability of an incident. And this type of technology currently is available as a standalone face shield up to 20 calories. It's actually the gray infrared dye or IR dye that provides the protection from an arc flash. If you recall a few slides ago, I showed that breakdown of an arc flash, and the first stage is that radiation wave. Well, that radiation wave contains the infrared that burns the worker. So traditional face shields in the market are green or have that green dye, which is an IR dye that activates to prevent that thermal energy from transferring through that material and burning your face. So the newer technology available in the market is gray, which is safer than green in terms of color perception. And that gray is the IR dye and provides the protection from the arc flash. How does that work? Well, gray is a medium density filter. In layman's terms, it simply blocks the entire wavelength of light. So we have the full spectrum that is visible to the worker. When you're using a traditional green face shield, there's actually yellow mixed in with that because yellow makes our eyes more sensitive to light. So in a way, it's tricking the worker to believe there's more light on the work task. However, what it's doing is it's changing the perception of the worker's color acuity. If you're looking at colors that contain yellow, yellow being a primary color, well then those colors have now changed. So an example would be using the color wheel. This shows us the primary colors and then how we can make new colors. Traditional green, yellow arc flash face shields and suit hood shields alter a worker's color perception. And an example of that would be using just this little scenario I built here, which is a relay with some different colored wires. On the left-hand side, if I ask you to find the green wire or identify the green wire and the blue wire, on the left-hand side, it shows that the green wire is in front and in the back is the blue wire. However, if you look through a gray face shield, which provides true color acuity or true color perception, you have on the back, you have the green wire and the front is the blue wire. So we could easily see using this example how mistakes could be made by wearing traditional arc flash PPE, and the new technology allows us to see clearly and accurately. So true color gray hoods, that same lens technology that's available as an arc flash face shield is available in hoods. So it's safer than green. Workers can see the full color of their work tasks. And this technology now, and again, we were testing with this technology just last week, it's available right up to 100 calories. It prevents having to lift the front of your hood to accurately determine the colors. And then you can add features that help with your productivity and comfort, such as the LED lamp and hood ventilation systems. The lighter weight fabrics, just imagine having to wear a heavyweight arc flash suit. And I got my start in this industry about 12 years ago when arc flash suits were really heavy to wear. They were nicknamed everything from bomb suits to Homer Simpson suits or space suits, and everything was difficult. Just walking to your work task was difficult. Now the lighter weight fabrics allow for mobility and the increased worker productivity. So if workers are not suffering, if they're not burdened by wearing their PPE, they're going to be clear of mind. They're going to be able to perform their work better, and they're going to make less mistakes. So these functional designs go a long way to optimal worker safety. And then the comfort options reduce heat stress as well. So such as an arc-rated cooling vest that you could wear underneath the suit or over top of your daily wear. The ventilation systems. This image here shows the side shot of me wearing an arc flash suit. You can see that the hose at the back, which is that small little fan unit that brings air, external air inside the hood, and then that air is actually diverted up and around and down the inside of the lens. The purpose of this is to deliver the air to the breathing zone for the worker to be comfortable. We want a gentle flow of air that's delivered right to where they need it, right where their breathing zone is. And we also want that air, the external air, at its external temperature to run down the inside of the lens. So one of the concerns that I often hear from different employers about traditional arc flash PPE is fogging issues within their hood, in particular in the winter months. So if you have an anti-fog coating on the inside, well, that typically works really well in ambient temperatures or just your typical 70 degree and warmer temperatures. But when it's really cold, your anti-fog doesn't work very well. So by bringing external air that is cold from the outside inside, it prevents any of those fogging issues whatsoever. So it keeps your worker productive as well as being comfortable. And here we have just a common example of one of the FAQs I get when I frequently asked questions, such as the type 2 hard hat. So in Canada, we have two different types, or type 1, type 2. Some of the provinces require by law that you wear a type 2 hard hat. If you determine the type of hard hat based on the risk or the severity, so the potential injury to the worker, many employers have determined that a type 2 is necessary based on the potential flying debris created by an arc flash. And that foam liner in a type 2 provides that side impact protection. The question I often get is, well, what happens to that foam in the event of an arc flash? Many, many years ago, Oberon had conducted testing using the available type 2 hard hats in the market. You can see the old green lens or green face shield used in this test setup here. We even turned it around backwards because when you have a face shield and the hard hat and you're facing the arc flash, well, that system provides protection and it prevents any of that thermal energy or sufficient enough thermal energy to come through that lens to have any issue with that foam inside liner. Now, I actually asked them to turn it around backwards so we can expose the suspension as well as the hard cap itself to the full extent of that thermal energy. And you see in the bottom image, we still don't have any melting, dripping, or anything that would have caused any concern. So the incident energy exposure was no greater than, say, 28 calories. Mind you, you should never be wearing an Arc Flash face shield for exposure greater than 12 calories. So this is just one of those examples, and I'm going to put up my contact information for any of the questions you might have regarding Arc Flash PPE. Please send me an email or contact me. I have a wealth of resources that I've created over the years that could be of assistance to yourselves. I'm happy to help to answer any questions that you have regarding Arc Flash PPE. I want to thank EasyPower for allowing me to be their guest presenter and provide this webinar for you this week. And thank you for attending. Again, my name is Jim Pollard, and if you have any questions, please contact me, and I hope to help.
Well, I certainly get a lot of information out of this presentation and the topic every time we go through it. So I hope others benefited as much as I did watching the details that Jim provided. This, as I mentioned, is our last webinar for the year. Certainly, we very much appreciate your participation and your support. And so we'll look forward to you joining us next year. Have a safe holiday. So long.